All right, the next type of graph, we raise it to a power. First thing to notice, if y is function x to the power of n, if I was to differentiate that, bring down the power, lower the power, diff the inside. So here's the derivative of my new graph. Notice it's times f dash x. So if it is a stationary point on the original graph, f dash x would be 0. So therefore, the derivative of my new graph will also be 0. So what that's saying is, wherever there's a stationary point on the old graph, at that x value, of course the y value may well change, but at that x value, there will remain a stationary point. But also look inside here, function x. If function x equals 0, we're now going to get a stationary point as well. Because the derivative is, and there it is, function x times that. So any x-intercept of the original curve will become a stationary point. Okay? So all stationary points will still be stationary points. Yes, the y value might be different. We're talking about the x value. But here we go. So here's random graph. I'm going to do function x squared. We're going to square the graph. Now, if I square a number bigger than 1, obviously it's going to get bigger. So the y value has increased. But I know that's going to be a stationary point. Down here, you might, if you are very observant, you will notice I changed the scale a little bit. So this turning point is clearly above -1 in this case. Square that number, the number's going to become smaller, but it's also going to become positive, of course. So it's actually on the other side of the x-axis. So our x-intercepts will also become stationary points. So there's a stationary point, there's one, and there's one. So we know they're all the stationary points. Vertical asymptote will remain. All of a sudden it can't magically come into the domain. My horizontal asymptote is less than 1. So when I square it, it gets smaller. So it's dropped down a bit. Now, look at this close. And 1 becomes a key point, because if you square 1, you get 1. Now, I'm just talking about absolute value here, because I'm not worried about positive or negative. But if you've got a number that's bigger than 1, then the new graph must be above the original curve, because y value will increase. If its original value is less than 1, then it must go below the original curve. Okay. Let's put in 1 so I know what to work with. Here's what happens. Now, the original graph is less than 1, so my new graph will go below. Then it will hit 1 and go above. Ooh. Oh, yes. I need to plot in that point there, because that's where it was -1. Square -1, you get +1. Let's have a look. So it goes below, above. Now over here, it goes below, but it's now positive, so it's a bit hard to see that. But then above, on the positive side, it's easier. Below, above, below, also below, but in the positive side now. Whoop, and below the horizontal asymptote. So there's function x squared. Another reason I know each of these roots here are going to be turning points is think back to polynomials. See, if the original graph, it's just cut through it, it must have been to the power of 1. So when I squared it, it becomes to the power of 2, and we know the roots behave like the power. Let's cube it. So that was an even one. So when it's even, it's always positive. Odd, we're going to have the same sign. So let's do cubed. Same sort of idea. Well, cube a number bigger than 1, then now goes really big. Number smaller than 1, well, it comes up a bit here. It's going to be a much smaller number there. 0 is still 0. They will still be stationary points though. So therefore they're going to be, alright, so there'll be horizontal points of inflection as we go through. There's my horizontal. So again, I'm cubing something smaller than 1, becomes really small. What else we got? Oh, vertical asymptote's going to remain. Now let's, there we go, cube 1, we get 1. Cube -1, we get -1. And we're still going to have above, below, below, above, and all that sort of idea. Yeah, it's really hard to do this in PowerPoint, by the way. That's meant to be a horizontal point of inflection as it goes through. So there, whoop, inflects, goes up, whoop, inflects, turns, inflects. Oh, there is my attempt at making those inflect as I go through. So that's the idea of powers.